Hello everybody, my name is Stefan Budo. I am a Microsoft Azure MVP and a solutions architect working at Vigilant IT based in Sydney, Australia. This webinar will take you through discussing OMS with a focus on availability with Azure Backup and Azure Site Recovery. I will start with some slides to give you a good high-level overview of both products and then run you through some demos to show you how Azure Backup and Azure Site Recovery can help you protect your critical workloads. So what is OMS? OMS stands for Operations Management Suite. It gathers data from servers throughout your IT infrastructure and consolidates that data in a single management interface. That data might include diagnostics, logs, performance, or alert data from both Windows or Linux computers. Alerts in OMS can automatically inform you by sending an email notification, and OMS can auto-remediate issues with Azure Automation Runbooks. What do you get in OMS? You get insight and analytics, gain immediate insights across workloads, tap into operation intelligence when it matters to explore, analyze and take action faster. Automation and control. Enable consistent control and compliance. Deliver continuous IT services and remediate issues quickly and at scale. Security and compliance, of course. Response faster to security threats. Identify emerging threats to protect your critical data and workloads. And finally, protection and recovery. To ensure availability of your application and data. Simple, automated data protection and disaster recovery in the cloud. This presentation will focus on data protection and disaster recovery. Let's start with data protection. Data is the currency of modern businesses, but in today's digital world, the amount of data organizations are creating and collecting is growing by over 40% per year. According to some analysis, 90% of the world's current data was created in the last 2 years. Those amazing facts lead to an ever-increasing cost to store and manage this data. Although the cost per gigabyte drops every year, it doesn't do so at the same rate as the data growth. This has a direct flow-on effect on the cost of backup. Next to purchasing a solution, running it, and training your IT staff to use it, the cost and complexity of managing the storage is a major factor. Think about how much is spent purchasing disks and backup media, storing them, but also testing them in order to guarantee you can recover data from a tape that is 5 years old. All these challenges often leads to the possibility that important data might not be backed up at all. With Microsoft Azure Backup, you can eliminate expensive disk and tape costs and ensure all your data is protected. It will enable you to either supplement your existing on-premises backup solutions or replace them entirely at a lower cost with a scalable, reliable, secured, and encrypted cloud-based solution. Here are a few features of Azure Backup. There's no more need for tape backup, and therefore maintaining an expensive offsite storage facility becomes redundant. This helps protect data against loss and corruptions. Protect your on-premises VMs running with Windows or Linux on Hyper-V or VMware at the hypervisor level, but also your virtual machines already running in Azure. Long-term retention enables you to keep your data for up to 99 years and meet any legal and compliance requirements. It provides a consistent experience configuring, monitoring, and recovering backups across local disk and cloud storage, integrating with the Inbox backup program in Microsoft Windows Server or System Center Data Protection Manager. Azure Backup supports a variety of applications such as SQL servers, SharePoint servers, Exchange, file servers, and even Windows client computers. Enjoy the confidence that your data is safe with Azure's cutting-edge and certified security, privacy, and compliance practices. Azure is certified many times over with the International Organization for Standardization. Some of those certifications include the ISO 27001, This certification outlines hundreds of controls and control mechanisms to help organizations of all types and sizes keep information assets secure. In February 2015, Azure became the first cloud computing platform to conform to the ISO 27018 Code of Practice for the protection of personally identifiable information in the public cloud. And in September 2016, Azure was the first hyperscale cloud provider to achieve the ISO 22301 certification with the assurance that you can now trust Microsoft Azure with your mission-critical applications and Azure's unmatched business continuity and disaster recovery preparedness. Protect workloads running on any cloud, hosted, public or private. And finally, cost-effective solution metered by usage which transform your capital expenditure into a controlled and defined monthly operating expenditure. Microsoft Azure Backup comes in 4 different flavors to encompass your business needs. Are you already using System Center Data Protection Manager? Azure Backup easily integrates with the product, allowing you to start using the Azure Cloud as your long-term data repository. You don't have Data Protection Manager? No problem. You can download Azure Backup, which has almost all the same functionalities as Data Protection Manager, for free from your Azure subscription. Do you need to protect a branch office or a small business? Microsoft Azure Backup integrates with Windows Server Backup Tool, allowing you to protect your applications and files directly to Azure. This method can also be used to protect user data on workstations or laptop. And finally, if you have virtual machines already running in Azure, you can now simply back them up from the Azure portal. With Azure Backup, you have the confidence that your data is safely stored in the cloud. Before your data is copied to Azure, it is first encrypted with your own encryption key. It is then sent to your backup vault where it stays encrypted until you decide to restore the data, at which point it will get decrypted with your key at your premises. At no point during this process does Microsoft have any access to your data, so if you lose your encryption key, no one will be able to recover your data. That's how safe it is. Let's go to the Azure portal where I can get you excited about starting to protect your data today. So in this demo, I'm going to show you how to get started with the different flavors of Azure Backup. As you can see, I'm already logged on into my Azure subscription. So the first thing we need is to create a recovery service vault. This vault will contain all the information and data that relates to the protection of the workload. Note that a vault will be able to contain both Azure Backup and Azure Site Recovery data. To create the vault, we go into the Recovery Service Vault section. I already have a few vaults in this subscription, which we could use, but for this demo, we'll create a new one. We will then need to enter a few details such as the name of the vault, which has to be unique within the subscription. We can select the subscription we want the vault to be created in, either create a new or an existing resource group, and finally, select the Azure Data Center where the vault will be located. Now that we created our vault, we can access the dashboard. This will show us some information about the vault, statuses of backup and site recovery, but also give us access to the settings where we'll be able to set up our backups. So first, we'll set up a backup for an Azure virtual machine by going to the Getting Started section, then Backup. We see here a 3-steps wizard. In the first step, Azure will ask you some basic questions to determine what to do next. Where do you want to backup from? In this example, Azure. And what you want to backup? A virtual machine. In the second step, we're going to define what our backup policy is for the virtual machine we want to protect. This policy will dictate how often we run our backup and how long we keep the backups for. We can either select an existing policy or create a new one. You can see, if we wanted to create a new one, that we can get very granular in terms of retention and potentially keep our backups for 99 years. But for this demo, let's just use the default policy, which is to backups once per day at 12:30 AM and retain the data for 30 days. And finally, we can now select the virtual machine we want to include as part of this backup. After we confirm our selection, Azure will start the initial seeding of the data from the selected virtual machine to the vault. Once the initial data is uploaded in the vault, the backups will run according to the schedule defined by the policy. Now that the initial seeding of the data is completed and the virtual machine is backed up, I can show you how to restore it. We can see here we currently have one Azure virtual machine backed up, which we can select. This will show that our last backup was successful and allow us to drill down to see additional information such as how many restore points we have and what is the backup policy selected for this virtual machine. Note that we can initiate a manual backup outside of the assigned policy by using the Backup Now functionality. But for now, let's focus on restoring the virtual machine by clicking on the Restore VM button. This brings up a two-steps wizard. In the first step, we're going to select which backup we want to restore from. There are three types of backups within Azure. Application consistent. This is the best one, but only works with Windows guest operating system. The backup will be taken using a VSS application consistent snapshot, which ensures that the server will boot and there is no data loss. In addition, the data will be consistent with the application. File system consistent. This type of backups ensure that the server will boot and there is no data loss, but will not be consistent with the application. This will happen for a Linux guest operating system backup or if something goes wrong with the VSS during a Windows backup. And finally, the crash consistent backup. This will usually happen if the virtual machine is switched off or crashes during a backup. In this case, there is no guarantee that there won't be any data loss or that the server will even boot. Let's select the only backup we have in this case, which is the application consistent one, and confirm our selection. Next, we'll need to enter the restore configuration. The name of the restored virtual machine. This can be the original name to override the existing virtual machine or an alternate name to create a restored copy of the virtual machine, which is the recommended approach, of course. The name of the resource group this restored virtual machine will be part of, what virtual network you want the virtual machine to be attached to along with the subnet, and finally, the storage account that is going to be used to host the virtual machine's data. Once we've entered all the required details, we can start the restore. This will launch a restore job, which can be monitored from the backup job section. You can see here the job is in progress and we can drill down this section to get additional data on the running job. Now that the restore job is completed, we can go to the virtual machine section and see that our additional copy of the virtual machine has been restored and can be accessed just like any other virtual machine you would have created previously. Okay, we've just seen how we can backup and restore a virtual machine in Azure. So now I'll demonstrate how to backup and restore files and folders on an on-premises server using Azure Backup. We're back in the vault we created earlier, where we have our existing Azure virtual machine still in the backup rotation. To add our on-premises backup, we go to the same Getting Started backup menu, but in the first step, instead of selecting Azure as our location for the workload, we can now select the on-premises option. The backup selection has now changed to show all the different supported applications such as Hyper-V virtual machines, SQL servers, SharePoint, Exchange, or even system state and bare metal recovery. All these type of workloads will however require an on-premises Azure backup server to be set up. So the one we're interested in this demo, which only requires a local backup agent to be installed, is files and folders. After confirming our selection, the second step will be preparing our local server. We will need to download and install the backup agent on the local server, as well as download the Vault credentials file, which is our encryption key. This key will be used during the server registration to Azure. Let's download those two files now. Once our downloads are completed, we can switch over to the on-premises server and go through the agent installation and configuration. I'm now connected to the console of the server in my data center, and you can see here both Azure Backup installation and Vault credential files are downloaded earlier. Let's go ahead and install the agent on the server. When the file extraction and the prerequisites are installed, an installation wizard appears. The first thing we need to define is where the agent will be installed, but also the cache folder location. This folder will be used as temporary storage during backups. The location specified must have free disk space, which has at least 5% of the backup data. We can then define the use of a proxy server to access the internet. Note that the agent will only communicate over HTTPS. And finally, we confirm our choices and go ahead with the installation. After the installation is completed, we can now proceed to the server registration, which will establish the secure connection to our Vault in Azure. Here, we specify where the agent can find the Azure Vault key we downloaded earlier. We can validate the Vault information and move to the next step, which is to set up our personal Vault encryption key. As I mentioned during the presentation, this key will be used to encrypt all your data before it's sent to Azure. Since no one without this passphrase can access your data, even Microsoft, it is important to keep it safe. This is why a location needs to be entered here, which will ensure a file is created with the passphrase in it. Once the connection is successfully established to our Azure Vault, we can now start the Azure Recovery Service Agent console to set up our backup to Azure. From this console, we can now check or change the properties for the agent, such as changing the passphrase that we used during the initial setup. Also add or change the configuration for the proxy server. But more importantly, through the throttling tab, we can set a limit on how much bandwidth can be used by the agent so that you don't suddenly saturate your internet connection with backups. We can set different throttling values for within or outside of business hours and define those hours with the schedule below. Now that we completed the configuration, let's start protecting our data. The scheduled backup link will display a configuration wizard. The first step is a simple introduction, letting you know what information will be required during the wizard. Next, we'll define what files and folders we want to protect. Now for this demonstration, I created a folder called Demo Data, along with a subfolder and a test file, which we are going to back up. We can see a list of our backup selection, and from here, potentially set up an exclusion list if we don't want to back up specific files within some folders. In this third step, we'll define our backup schedule. We can either define a daily or a weekly backup with a maximum of 3 backups per day. Next, we can now define a retention policy in Azure. This might look familiar, as it is the same retention settings we've seen earlier in this demo when backing up an Azure virtual machine. You can set up a daily, weekly, monthly and yearly retention policy. For this final step, we can define whether we want the initial data seeding to happen across our internet connection, or alternatively, if the data is sizable, you can copy it onto a removable hard disk and ship it to Microsoft so they can import it for you. We can now review and confirm our configuration. Although we have a backup scheduled to run later on, let's create a manual recovery point so I can quickly demonstrate how you would restore a file if it got corrupted or deleted. We see here that our last backup was successful. So let's go to our demo data folder and delete one of the files so we can restore it. To restore this file, or any folder, we start the recovered data wizard and first select if we want to use this server or any other server on the network. We can then either browse our Azure Vault for the files we're looking for, or enter the name of the file or parts of it in the available search function. Since we selected to browse the vault, we will need to select the volume the data was located on, then select the date and time we want to recover from. A calendar allows you to easily see at what date recovery points are available, and within the selected date, the time it was taken. Next, we'll go ahead and select the file we want to restore. You could here also select an entire folder or multiple files at once. Finally, we define if we want to recover the file in its original location or a different one, as well as defining what to do if the file already exists in the destination folder. In addition, we can also choose to recover the NTFS permissions on the file. After we confirm our selection, the recovery job starts. As soon as the job is completed, we can see that our file has been recovered in its original location as we defined and is now accessible again. If we now quickly switch over to the Azure portal, you can now see that in our vault, under the backup tile, we have a file folders item, which we can drill down into to see more details such as the name of the protected server, backup items, and also the number of recovery points available. Although this concludes the Azure Backup demonstration for today, this is only a small subset of use cases and functionalities in Azure Backup, but unfortunately, due to time constraints, we won't be able to demonstrate them all today. Now that we've seen how Azure Backup can help you protect your workload, let's take a look at the business continuity and disaster recovery solution. Before we dive into Azure Site Recovery, let's take a look at what a disaster actually is and why your business should be concerned. There seems to be a misconception by the majority of IT professionals that when we talk about a disaster, we refer to a large environmental catastrophes such as flooding or earthquakes, which induces a false sense of security by fueling the "that's never gonna happen to us" attitude. The most common causes of IT disasters are often overlooked. Hardware failures, human error, or malicious intent can all cause a critical application to go down. I have seen an entire ERP system go offline because of a viral infection. So it is important to understand that an event does not have to impact your entire data center to become a disaster. But when a disaster does happen, what do? Believe it or not, the most common disaster recovery strategy out there is not to have one at all. Small and medium-sized businesses often can't afford to implement an adequate disaster recovery plan, so they fall back onto the cheaper alternative, which is to restore from backup if something goes wrong. Although this method often works, it takes hours, if not days, to recover the systems when a disaster happens. And the data loss is often bigger than what was originally expected. But modern businesses can't afford downtime, so traditionally, truly protecting all your critical applications required building and maintaining a secondary data center, which was a costly undertaking. The ongoing expenses associated with operating this data center was a massive monetary commitment, which included IT maintenance personnel, hardware refreshers, utilities, and more. Now, you do have a cost-effective alternative in Microsoft Azure Site Recovery. It lets you rest easy knowing that all your workloads are protected from any disaster, without having to build and maintain a secondary data center or rely on your backup strategy. Azure delivers cloud services that extend your data center and protect your infrastructure, transforming your business with a true hybrid solution. With Azure Site Recovery, you no longer need an expensive secondary data center to protect your application as you extend your data center to Azure. It can be used with different environments such as Hyper-V, VMware, physical servers, or even virtual machines running in other public clouds. Complex workloads such as SQL, Exchange Server, Oracle, SAP and more running on Windows or Linux are fully supported. You can test your disaster recovery plans without impacting your production environment, giving you the confidence that when a disaster does happen, you can fail over your system. Automation can also be used to enable the true power of recovery plans and allow you to fail over your workloads by the click of a button, removing the guesswork and stress often associated with a disaster. Recovery time objectives, how long it takes to bring your applications back online, and recovery point objectives, how much data can you afford to lose, are considerably reduced by ensuring near real-time replication and introducing automation. You can leverage the compute resources of Azure for dev testing by creating on-demand test copies of your production service in Azure without impacting your users. And finally, Azure Site Recovery can also be used as a free migration tool to permanently move your workloads to Azure for a true hybrid experience, reducing your infrastructure maintenance costs. There are several types of Azure Site Recovery models. The on-premises to on-premises model can be used if you already have a current investment in a secondary data center. In this case, Site Recovery can still be utilized as a management and orchestration platform across all your different types of environments, virtual or physical. If you have chosen Hyper-V as your virtualization platform, you can make use of your existing System Center tools to enable Azure to fully manage and automate a failover from your primary to your recovery site. Azure Site Recovery will also work with your VMware environment or even physical server for workloads that cannot be virtualized. If on the other hand, you do not have or do not want to invest in a secondary site, the on-premises to Microsoft Azure model is the solution for you. Azure Site Recovery provides the capability to replicate virtual and physical servers to Azure, which means you can avoid the complexity and costs of establishing and maintaining a secondary data center. You can achieve this with Hyper-V, with or without the use of System Center, with VMware, physical servers, but also from any other public cloud providers. The basic capabilities remain almost identical whether you choose to replicate to your own secondary sites or to Azure. Let's take a quick peek at what the architecture of Azure Site Recovery would look like with an on-premises to Azure protection model. As you can see here, we have both an Hyper-V cloud with or without System Center and a VMware cloud with or without vCenter along with a physical server. The first difference we note is that an Hyper-V environment can replicate virtual machines without any additional components, and does so with the help of an agent at the hypervisor level. While in the case of a VMware or physical server environment, we will need to install an agent inside the guest operating system. In addition, the use of a process server is required on premises, which will convert on the fly your data from either the VMware disk format or from your physical disk to VHD. The process server will then forward the converted data up to Azure. In both cases, the data changes will be replicated at determined intervals to a recovery service vault using blob storage in Azure. At the time of a failover, the data will be transferred to page storage, and Azure will create the virtual machines. This is an important point as it highlights that during normal replication operation, no virtual machine resources are used in Azure. Only when you initiate a failover will those resources be created, which means you won't pay for those until such time. Now that we've seen an overview of Azure Site Recovery, I'd like to dive in the Azure portal to give you a quick demonstration. So in this demo, I'm going to show you how to set up Azure Site Recovery to protect a virtual machine running on Hyper-V in your data center to Azure. For this to happen, we need a recovery service vault. Since we already created one in our previous demo about backup, let's reuse it and simply add Azure Site Recovery to it. Alright, so the next step is to establish a connection between our Vault and our Hyper-V server in our data center. In the Getting Started section, this time we select the Site Recovery option and see a 3-step wizard. The first step will guide us through establishing the connection between our on-premises server and Azure. We see here the 5 steps necessary to create this connection. The first one is to tell Azure some information about what we are trying to do. Where do we want to replicate our virtual machines to? In this case, to Azure. Is our server virtualized, and if so, on which platform? Note that you can also select VMware or physical machines, but for this demonstration we'll select Hyper-V. And finally, in our example, Azure would like to know if we are using Virtual Machine Manager for ease of management. After we confirm our answers, the wizard will take us to the second step, in which we need to create an Hyper-V site. This Hyper-V site is a group that will contain all the protected Hyper-V servers located in the same data center, for example. This group of servers will also have the same replication configuration as we'll see later during the setup. Once our site is created, let's go ahead and add our Hyper-V server. To do so, we must first install and configure the Azure Site Recovery Provider application on the server itself, then establish the connection to our Vault using a Vault key, which is our encryption certificate. You can download both Providers and Vault key from the links here. I'm now connected to the console of the Hyper-V server in my data center and have downloaded both Azure Site Recovery Provider installer and the Vault key from the link mentioned earlier. Let's go ahead and install the provider on the server. The first thing we need to define during the actual setup is for the agent to use Windows Update to stay up to date. We highly recommend to leave this option turned on. We can then also change the path where the agent is installed on the server and confirm our selection. After the agent installation is complete, we can now register our server to our Azure Vault. The first step is to tell the agent what encryption key to use by selecting the Vault key we've downloaded earlier from our subscription. You can confirm that the key is correct by verifying the subscription ID, Vault and site name. We then define if our server requires a proxy server to access the internet. Note again that in the same way as Azure Backup, the Azure Site Recovery agent will only use HTTPS to connect to the Vault. After we confirm our choices, the agent is going to establish the secure communication channels with our Vault, and the installation is completed. Coming back to the Azure portal, we now see our server has been successfully connected to our Vault. Note that it can take up to 30 minutes for the server to appear. Let's move on to step 3, which will allow us to prepare the Azure environment for a failover by defining in what subscription should the virtual machine be deployed in case of a failover. What deployment model should we use? The new ARM model or the classic ASM? It is also going to verify that there is at least one appropriate storage account and a virtual network has been created. If the system cannot see one, we have the option to create one of each day. Now, I've already pre-created the storage accounts and virtual network as these are beyond the scope of this demo, but once they are created, you can move on to the next step. Here, we're going to define the replication policies associated with our Hyper-V site, which, as we've seen before, contains our Hyper-V servers. To create a new policy, click on the Create and Associate button. The following information will be required. The policy name. This name has to be unique within your subscription. The source and target types have already been defined in step 1. The copy frequency, which is how often the data should be replicated from the data center to the Azure Vault. This can go as low as 30 seconds and represents the RPO, the recovery point objective. We then define how long we want to keep the recovery points for. This will allow us to fail over from previous snapshots, which is a very useful option in case of a virus infection, for example. Next, we enter how often should the synchronization be application consistent. This type of replication is going to trigger the VSS writer to create an application consistent snapshot of the protected virtual machine. And finally, we define when the first replication should start, either immediately or at a certain time in the next 24 hours. When we are happy with our configuration, we can confirm our choices and move on to the fifth and final step in our setup. In this final stage, we want to ensure that the appropriate amount of storage, network bandwidth, and other resources have been assigned so Azure can meet the defined replication needs. Using this link, you can download and complete a capacity planner. This will help you understand your specific resource requirement for Azure Site Recovery. Once this has been completed, we can answer yes to the question and finish our setup. Now that we have connected our Hyper-V server to our Azure subscription via our Vault and defined our replication policies, it's time to put this setup to good use and start protecting a virtual machine. This is enabling Step 2 Replicate Application, and by following the 5 steps wizard. In this simple first step, we're going to select the source of our replication, an Hyper-V site, which we defined earlier and contains our Hyper-V server and replication policy. Next, we're going to define our target system, in this case Azure. In this step, you can select what subscription the failover virtual machine should be under, as well as under what model they should be deployed, Resource Manager or Classic ASM. The storage account that the virtual machine should be using during the deployment, and finally, the network subnet it should be connected to. This third step is where we are going to select what virtual machines we want to protect. Azure has pulled a list of all existing virtual machines currently deployed on the local Hyper-V server. In our case, I'm going to select the demonstration virtual machine that has a SQL database installed on it. Next, we're going to tell Azure what operating system is currently running on the local virtual machine, as well as selecting the OS disk. In this example, my virtual machine has only one virtual disk to select from. Confirm our choices to move to the final step. Finally, select the replication policy associated with this setup, the one we created earlier, and finalize the replication. Now, depending on the choices we made earlier, this will trigger the initial data seeding from our on-premises server to Azure either immediately or at a scheduled time. Our replication is now completed, and we can see that in the site recovery tile, we now have one replicated item. If we click on the tile, a list of all replicated items is shown, which in our case is our test SQL server. We can drill down the server to get more information, such as the current replication policy, target storage accounts, source location, etc. But also configure what the resources of the virtual machine should be in Azure when a failover is initiated. You can name the virtual machine, define how many virtual CPUs, memory, and network cards will be assigned, as well as define what target virtual network the machine will be connected to. Going back to the overview, we can see 3 options for failover: a test failover, an unplanned, and a planned failover. The test failover allows you to test your failover plan by bringing up the virtual machine in Azure without interrupting your production server. This also means that it will require an additional virtual network to be connected, so it doesn't create a conflict with the production machine. The difference between the planned and unplanned failover is that the planned failover assumes that the server is still up and running and will do a last synchronization and shut down the virtual machine before failing it over to Azure. An unplanned failover, on the other hand, is more appropriate in case of unforeseen failure by the server and the server is no longer accessible. For this demonstration, we will simulate a failure on the virtual machine by switching it off and do an unplanned failover. Let's go on the local Hyper-V server so I can show you the SQL database running on the server. As you can see, I have a simple database with a simple table on this server. Let's add a record to the table. Since we've set up the replication to happen every 30 seconds, we should see this new record on the failed over server in Azure. Now, we'll switch off the server to simulate a failure. Back in the Azure console, we now click on the Unplanned Failover button to initiate the failover. Note that this step can of course be automated, but for this demo we'll do it manually. The failover direction will be from our site to Azure. And you can ignore shutting down the server option because, well, it's an unplanned failover, so it's already off. So let's click OK to start the process. As soon as the failover is completed, we can now go have a look in the virtual machines section and see that we now have a ASR demo server up and running. If we connect to this server now, log on, and start the SQL Management Studio, you can see that our database is up and running. And if we drill down to the table and display the records, you can see that the record we've added before the failover is present in the table. This is of course a simple demonstration, but it does show you that you can easily set up a replication for your servers, then develop recovery plans for failing them over in case of problems. Now that we are happy that the failover has worked, we can go back to our recovery service vault, select our virtual machine and complete the migration process, which would tell Azure that the production machine is now running in the cloud. Okay, so where to start from here? An OMS proof of concept can be an easy introduction to Azure Backup and Azure Site Recovery, but also any other features within OMS that we've covered or will cover during our webinar series. And if you qualify, you could take advantage of the OMS Accelerate offer to have Microsoft fund the OMS proof of concept so you see for yourself the advantages of the operations management suite in your data center. For more information, simply email us or visit our website. Alright, that's it. Thank you for watching and don't miss out on our next webinar where we will talk about OMS automation. I hope you enjoyed this presentation and that you'll soon try out OMS.